Hello, this is Miss Cliffner with your video lesson for today. The camera was freezing, so I'm not recording my video face, just my voice. So we're looking at using addition or subtraction to solve an inequality. The homework is informative. So here's a warm-up. I'm just going to go through the first two. Because solving inequalities is very similar to solving equations, I'm going to draw the balance scale. I'm going to look at the side with the variable, and I want to get the variable by itself. I'm going to subtract 2 from both sides. I end up with a 0 pair that cancels out. I get k equals 12. I'm not going to check my solution. I'm just practicing solving right now. For b, I look at the side with the variable. I undo subtraction, which means addition. So I need to add 7.5 to both sides to get the variable on the right-hand side by itself. That's a 0 pair, leaving me with just m on the right-hand side. And then I add 5 plus 5, and I regroup the 1, and I get 11. M equals 11. Okay, so now I'm going to get into the lesson, and I want you to see that today's lesson, right, this was from a while ago. This is when we first started solving equations. We used addition and subtraction to solve an equation. Today we're using addition and subtraction to solve an inequality. So this is the big idea from yesterday's record and practice journal. The situation was you had a friend that in 3 years was still going to be less than 18, which meant that right now your friend's age is less than 18. So the idea is I took the, we put an equal sign in and we did some solving. Now I just leave the inequality and I look at the side with the variable and I do the opposite operation. I subtract 3 from both sides. I get x is less than 15. Same thing with this one. This was the manatee that starts out at 4 feet and it grows to less than 13 feet. I subtract 4 from both sides, which means the manatee grows less than or equal to 9 years. That's what we're doing today. Just like solving equations, we're now going to solve inequalities. Okay, this is what the information in your textbook. I want you to see that this is super important. You use inverse operations to get the variable by itself. And I want you to think about this. It's not an equation anymore that shows that two sides are equivalent. It shows that two sides are actually out of balance, right? So if this is you, right, your sibling is 3 years older. In 3 years, they're still going to be 3 years older. So as long as you do the same math to both sides of the inequality stays in balance the same amount, or stays unequally balanced. Okay, here's our steps for solving equations. You'll look at the variable side and do the opposite operation. Whatever you do to one side, you do to the other, and then you plug it in. But now, I'm going to add a few more steps. So I'm going to put this up here, and move this up here, and then bring this to the front. Okay, let's go ahead and fill in the notes for today. You're going to pretend that the inequality has an equal sign. Then these two are the same. Look at the side of the variable, do the opposite. Whatever you do to one side, do to the other. Now, instead of plug it in, we're going to go ahead and graph the solutions with an open or closed circle, and then the arrow will match the direction of the inequality if the variable is written first. Then you've got two checks to do. One is called a circle check. You're going to change the inequality to an equal sign, and then you're going to plug in the number where we have the circle. You're going to check to see if it makes it true. The second check is an arrow check. You're going to choose a value in the shaded region and plug the number into the inequality to make sure it's true. If it's not true, your arrow is going the wrong way. Okay, so let's see what it looks like. Here's an example. Right over here, I'm rewriting the inequality here so I have room to solve it. Okay, so here's my inequality. X minus 3 is greater than 1. I draw the balance scale. I look at the side with a variable. The opposite of subtracting 3 is adding 3. I'm going to add 3 to both sides, 0 pair. I know X has to be greater than 4. So I'm going to go to my number line. I'm going to put a 3, 4, and a 5. Greater than is an open circle. I put an open circle on 4. I'm looking to graph all the solutions that are greater than 4, so the arrow goes off to the right. Now when I check it, the circle check, I look back at the original inequality and I make it into an equation. I'm checking to see, is the circle in the right place? So I have to check and see, if I plugged in 4 where my circle is, if that was the only solution, is it correct? And that is where my circle is. So I'm going to plug in 4 minus 3 equals 1. I'm going to do the math. 1 equals 1. Check. My circle's in the right place. Now I'm going to check my arrow. I use the original inequality. X minus 3 is greater than 1. I'm going to plug in a number under my arrow. See how 5 is underneath the shaded arrow? I'm going to make it easy and just use the 5. So I say 5 minus 3 is greater than 1. Do the math. Is 2 greater than 1? Yes, it is. Check. Now I'm doing this in blue because I don't want you to write it down, but I want you to see what the arrow check does for you. What if I put the arrow off to the left and I made a mistake? Here's what my arrow check would look like. Maybe I'm going to pick 3 because that's underneath my arrow. And I plug in 3 minus 3 is greater than 1. And then wait a minute, I do the math and I get 0 is greater than 1. Oops, that's not right. That's how I know my arrow would have been in the wrong direction if I did that work in blue. Then I would make my arrow go off to the right and check it again. Okay, so now I've got some Oyos. I want you to try these on your own. Pause the video. You might want to start by rewriting it so that you have enough room. If you used my notes, it was a little bit tight on space. Okay, so you're going to solve it, then you're going to do a circle check and an arrow check. There's the balance scale. I look at the side with the variable. I add 6 to both sides. I get x is greater than or equal to 10. Don't forget, we're so used to putting an equal sign there. It's actually an inequality that we're solving, not an equation. Okay, I'm going to add 9, 10, and 11. It's a closed circle on 10. My variable is written first, so I know the arrow should match the direction of the inequality. For my circle check, I do x minus 6 equals 4. I'm going to plug in the number where my circle is, 10 minus 6 equals 4, and then I get 4 equals 4, check. Here's my arrow check. I'm just going to pick 11 because I can see it's under the arrow. So I do x minus 6 is greater than or equal to 4. I plug in 11. 11 minus 6 is greater than or equal to 4. I get 5 is greater than or equal to 4. Check. My arrow goes the right way. All right, next. Draw the balance scale. Look at the side with the variable. The opposite of subtracting 1 is adding 1. I add 1 to both sides. I get 11 is greater than or equal to x. Ooh, wait a minute. The x is on the right-hand side. I'm going to rewrite the whole thing by switching the variable, the sign, and the number. I'm rewriting it as x is less than or equal to 11. Now I know the arrow goes to the left. I'm going to make, let's see, 10, 11, 12. This is a closed circle. The arrow goes off to the left. I'm going to do the circle check for 11. 10 equals x minus 1. And I plug in 11 to see if that circle is in the right place, and it is. When I do my arrow check, maybe I'll pick 8 or 9 because it's a little bit further down where the arrow would be, right? It keeps going to the left. 10 is greater than or equal to x minus 1. I'm going to go ahead and plug in 9 minus 1. I get 10 is greater than or equal to 8. Yes, that is true. My arrow is going the right way. Just remember that when you rewrite it, notice the crocodile's eating the 11. When I rewrote it, the crocodile's still eating 11. Don't forget to change the direction of the inequality. Okay, last example and then some Oyos. 15 is greater than or equal to 6 plus x. I draw my balance scale. I look at the side with the variable. This time I'm using subtraction because it's an addition problem. I'm going to subtract 6 from both sides. I get 9 is greater than or equal to x. Ooh, wait a minute, I want to rewrite it. X is less than or equal to 9. I rewrote it so that the arrow will match the direction of the inequality. I'm going to write 8, 9, and 10. It's a closed circle on 9. My arrow goes this way. Circle check. The circle's on 9. I'm going to do 15 equals 6 plus x. 15 equals 6 plus 9. I plug in that number and I do the math. Yes, the circle's in the right place. The arrow check remembers the original inequality. Do all the numbers underneath the arrow make the inequality true? I'm going to pick a number like, 8. 15 is greater than or equal to 6 plus 8. 6 plus 8 is 14. Yes, 15 is greater than 14, so it worked and my arrow is in the right direction. So here's the OYO. Try these two. Pause the video. Writing it over here so I have some room. Drawing my balance scale. Subtracting 2. 0 pair. Y is less than 15. So I'm going to do 14, 15, 16. Open circle. My graph goes to the left. All of those numbers make the inequality true. Circle check. Y plus 2 has to be equal to 17. Plug in the 15 where my circle is. I did the math correctly to get the circle. Check my arrow. Y plus 2 is less than 17. I think I'll pick 10. That's an easy number. 10 plus 2 is less than 17. Yes, 12. Last one. 16 is less than or equal to m plus 9. Subtract 9 from both sides. Sorry about that. School's almost over. All right, 0 pair. 7 is less than or equal to m, but I want to rewrite it so that m is greater than or equal to 7. Crocodile eating the 7s, m still eating the m. I didn't change the idea of the inequality. So 6, 7, 8, close circle because it includes the value 7. Draw my arrow this way, shaded in. Circle check. 16 equals m plus 9. That circle number is a 7. If that was the one solution, does it make the equation true? Yes, it does. But we know there's more than one solution because it's all the numbers that are greater than or equal to 7. I'm going to choose 8. 16 is less than or equal to 8 plus 9. Oops, I forgot to write the inequality. And when I do the math, I get 16 is less than or equal to 17. That is true. Okay, so good luck with your homework today. That's it for the video.